Hello, all you curious minds out there. Today's topic, as requested by Liz Skid, is gravity. Now, gravity might not be something you think about often, but it's always there, silently shaping our lives. It's an invisible force, yet it's one we can't live without. So what exactly is gravity? Well, in the simplest terms, gravity is a force of attraction that exists between any two masses, no matter how large or how small. That's right, whether we're talking about the colossal sun or a tiny pebble, each has its own gravitational pull. It's a universal law, a fundamental principle that governs the entire cosmos. Now, you might be wondering, but why don't I feel myself being pulled towards other people or objects? Why am I not stuck to the walls or ceiling? That's a good question. You see, while every object does exert a gravitational force, the strength of this force depends on two things: the mass of the objects and the distance between them. The Earth, being so massive and relatively close to us, exerts a much stronger gravitational pull than anything else around us. That's what keeps us grounded. It's why when you jump, you come back down. It's why the water in your glass stays put, and why your feet stay firmly planted on the ground. Yes, even though we might not always realize it, we're constantly living in the grip of Earth's gravity. And it doesn't stop there. Gravity extends far beyond our planet, reaching out into the vast expanse of the universe. It's what keeps our Earth in orbit around the sun and the moon in orbit around us. Gravity, though invisible, plays an essential role in our everyday lives. It's time to delve a little deeper into this fascinating force. Gravity is often referred to as a pull. But what does this mean? Well, to put it simply, gravity is like an invisible force that attracts objects towards each other. It's a bit like being drawn to your favorite food. The closer it is, the stronger the pull. Imagine for a moment that our universe is a vast cosmic dance floor. Every object, from the tiniest speck of dust to the largest star, is a dancer, moving to the beat of gravity's tune. That's right, gravity doesn't discriminate. It pulls on all objects regardless of their size or mass. Now, the strength of this pull depends on two things: the mass of the objects and the distance between them. The more massive an object is, the stronger its gravitational pull. That's why we're pulled towards the Earth and not the other way around. Earth is much more massive than we are. But here's where it gets interesting. The pull of gravity isn't just stronger for more massive objects. It's also stronger the closer objects are to each other. So, the closer objects are, the stronger the gravitational attraction between them. Think of it as a magnet. The closer you bring a paperclip to a magnet, the stronger the magnet's pull on the paperclip becomes. But just as the pull of a magnet weakens with distance, so does the pull of gravity. The farther apart objects are, the weaker the gravitational pull between them. So, if you could somehow move the Earth twice as far from the sun as it is now, the pull of gravity between the Earth and the sun would be 4 times weaker. It's this delicate balance between mass and distance that keeps our universe in motion. Planets orbit stars, moons orbit planets, and asteroids float through space, all under the watchful eye of gravity. So, in essence, gravity is the invisible string that pulls everything together. But how does it affect us on Earth? Stay tuned to find out. We've all dropped something and watched it fall to the ground. But have you ever stopped to think why this happens? Gravity is our silent partner, always at work, constantly pulling everything towards the Earth's center. It's like an invisible string that tugs at every atom, every molecule, every object in our world. Imagine if you could see these strings. You'd see them pulling at the leaves on the trees, the birds in the sky, and even the food on your plate. But what is gravity, really? It's a fundamental force of nature, an inherent property of matter that causes it to attract other matter. This attraction increases with mass and decreases with distance. That's why the Earth, with its vast mass, has a powerful pull. But if you were to travel away from Earth, you'd feel this pull lessen until you reached a point where you'd feel weightless. So why do things fall when you drop them? It's because of gravity. When you let go of an object, gravity pulls it down towards the Earth's center. The object accelerates as it falls, gaining speed with every passing moment. This is why the longer an object falls, the faster it goes. But gravity doesn't just pull things down. It also keeps us firmly planted on the ground. Without gravity, we'd float off into space. It gives weight to physical objects and causes the tides in our oceans. Gravity is like a cosmic glue, holding our world together. It keeps the Earth in orbit around the sun, and the moon in orbit around the Earth. Without gravity, there would be no stars, no planets, no galaxies. In a way, gravity is the ultimate power on Earth. It shapes our world and our lives in countless ways, from the falling of an apple to the rising of the tides. It's an unbreakable law of nature, as certain as the sun's rise and set. Gravity makes sure that what goes up must come down. But what about in space? Space is often called zero gravity, but is this really the case? Let's dive into the fascinating world of gravity in space. Contrary to popular belief, gravity does exist in space. Yes, you heard it right. It's just not as strong as it is on Earth. The strength of gravity depends on two things: the mass of the objects and the distance between them. So, as you move away from Earth, its gravitational pull on you decreases. Now let's talk about astronauts in space. It's not that they're experiencing zero gravity. Instead, they're constantly falling towards Earth due to its gravity. But here's the catch. The astronauts, the space station, everything inside it, they're all falling at the same rate. This creates the sensation of weightlessness. It's kind of like when you're in a lift and it suddenly goes down. For a moment you feel lighter, don't you? That's your everyday experience of weightlessness. However, this sensation is not because gravity has disappeared. Gravity is still there, still pulling. It's just that everything is falling together, which makes it seem like there's no gravity. This phenomenon is often referred to as microgravity, a state of very weak gravity. And what happens when there's very weak gravity? Things start to float. Astronauts can let go of a tool during a repair and it will just hang there in the air. They can even make water droplets float and they will move around like tiny glass marbles. It's a pretty cool party trick, don't you think? But don't be fooled. Even in these seemingly gravity-free scenarios, gravity is at work. The water droplet is being pulled by Earth's gravity, just like the astronaut and the tool. It's just that everything is falling together, giving the illusion of weightlessness. So, even in the vast expanses of space, gravity has a part to play. Let's wrap things up. We've talked a lot about gravity, but why is it so important? Well, gravity is more than just the reason things fall down. It's the invisible hand that shapes the universe, the glue that holds everything together, from the smallest dust particles to the largest galaxies. Consider our own planet Earth. Gravity is the force that keeps us grounded, literally. Without it, we'd float off into space. It's gravity that pulls everything toward the center of the Earth, creating the conditions for life as we know it. Speaking of life, even our bodies have adapted to Earth's gravity. It plays a crucial role in our weight, our muscle development, and even our sense of balance. That's right, gravity helps us walk straight. But the influence of gravity doesn't stop at Earth's atmosphere. It's the reason the Earth orbits the Sun, why the Moon orbits the Earth, and why we see those beautiful spirals in galaxies far, far away. Now imagine a world without gravity. Planets, including Earth, would not form in the first place. The Sun wouldn't exist as we know it, since it's gravity that causes the nuclear fusion at its core. And we wouldn't be here either. The universe would be an unrecognizable, chaotic mess of particles. But gravity isn't just about keeping things in order. It's also a key player in scientific research. Understanding gravity has led to breakthroughs in physics, space exploration, and even time perception. It's a fundamental part of the laws that govern the universe. So, gravity, it's more than just a force that makes things fall down. It's a fundamental principle that shapes our universe, our world, and our very existence. And there you have it, folks. Gravity, the invisible force that holds our universe together. Thanks to Liskid for suggesting this fascinating topic. Until next time, keep those curious minds active.